Questions 11 through 20 of the 2000 Grade 12 AMC 12. Two non-zero real numbers a and b satisfy ab is equal to a minus b. Find a possible value of this expression. So we have ab is equal to a minus b, and we have a over b plus b over a minus ab. And this is what they want us to figure out. So from this one, I will need to isolate for one variable, and then I'll substitute that into our bigger equation. So I'll bring the b over like that, and that equals a, and then factor out the b. You get a plus 1 equals a, and therefore b is equal to a over a plus 1, like that. And then substitute that into this expression. So we'll get a over a plus 1 for b, and then a over a plus 1 for b again, but this time in a different position, and then finally a times a plus 1. So here invert and multiply a plus 1 over a, invert and multiply 1 over a, and this looks like just a squared over a plus 1. So this cancels, so we have a plus 1 over 1 plus 1 over a plus 1 minus a squared over a plus 1. So we need a common denominator for the first fraction, so multiply top and bottom by a plus 1. So it becomes a plus 1 times a plus 1 plus 1 minus a squared all over a plus 1. And then now I'll multiply this out. So a squared plus 2a plus 1 minus a squared all over a plus 1. And looks like the a squareds cancel out. So I'm left with 2a plus 2 over a plus 1. Factor out the 2 on the numerator and we get a plus 1 all over a plus 1. And then finally, these cancel. So when it's all said and done, I am left with just the number 2. And that would be choice E. Let a, m, and c be non-negative integers such that a plus m plus c is equal to 12. What is the maximum value of this big expression right here? So we have a times m times c plus am plus mc plus ca. All right, so where do we start from in this question? This expression looks somewhat familiar but somewhat incomplete. It reminds me of something else. And what it reminds me of perhaps is a plus 1 times m plus 1 times c plus 1. And if I multiply all this out, I'm going to get amc plus am plus ac plus mc plus a plus m plus c plus 1. And this looks like what we have. This is the expression given to us is a part of what I just wrote out. And then this, they've also given us as 12. All right, so we can work with this. So the first part is what they want us to figure out. This part right here. And this part is 12, and that's 1. All right, so a plus 1 times m plus 1 times c plus 1. This is 12, and this is 1, so that becomes 13. So subtract 13 is equal to amc plus am plus AC plus MC. All right, so we have to maximize this. So to maximize that using AMC equals 12, you're probably going to have to use the maximum numbers for each of those. And the only way I think this will work is if the numbers are closest to each other or equal to each other. So A is equal to M is equal to C. If we do that, this will give us a maximum value. And in our case, since they add up to 12, they will all be equal to 4. A would equal 4, M would equal 4, and C would equal 4. So that would leave 4 plus 1, 4 plus 1, and 4 plus 1 like that, minus 13. And this is 5 times 5 times 5, which is 125, minus 13, and that would be 112. Now, if you're not convinced, if you think, well, why is that a certainty that that's going to make it this the maximum? Why, how about if you use other combinations? For example, if you used 3 for A and 5 for M and 4. Well, let's try. We'll have, therefore, 4 times 6, right, because I'm adding 1, times 5, minus 13. And this will give you 120 minus 13, which is 107. And similarly, any other combination for AMC would not give a number as high as 112. So the answer for this is E. One morning, each member of Angela's family drank an 8-ounce mixture of coffee with milk. The amounts of coffee and milk varied from cup to cup, but were never zero. Angela drank a quarter of the total amount of milk and a sixth of the total amount of coffee. How many people are in the family? So everybody drinks 8 ounces, right? So we'll let N be the number of people. And everybody drinks 8 ounces. So the total amount consumed is 8 times N. And all the beverages that they're consuming are basically a mixture of coffee and milk. So the amount of coffee, C, plus the amount of milk, M, is equal to 8N. So that's our first equation. Our second equation involves Angela, because they say that she consumes a quarter of all the milk, so M over 4, plus a sixth of all the coffee, C over 6, and that is equal to 8. Just 8 ounces because it's just Angela. And each member of the family drinks 8 ounces. That's what the question tells us. Okay, so we've got two equations. This equation I'm going to multiply through to get rid of the fractions and multiply it through by 24. So that would be 6M plus 4C is equal to 192. Yeah. So I'll call this equation 1 and I call this equation 2. And then we will therefore use those two equations to try to solve for N. So let's see, what can we do here? We can do 1 minus 4 times 2. I think that will get rid of something. Or rather, I think I had it reversed. 2 minus 4 times 1. So here we go. 6M plus 4C minus 4 times 1. So 4C minus 4M, and then the other side becomes 192 minus 32N. So the C's cancel, which is what I was trying to do, trying to get rid of at least one variable. So that leaves 2M is equal to 192 minus 32N. Divide through by 2, and that gives you 96 minus 16N. Now, the question tells you that the amounts of coffee and milk vary from cup to cup, but were never zero. So the amount of coffee and milk are never zero. So M is not zero, but M has to be some amount greater than 0. So if m is greater than 0, this is greater than 0. So that means that 96 minus 16n has to be greater than 0. So solving for this, put the 16n to the other side. We get 16n is less than 96, and therefore n is less than 96 over 16. N is less than 6. So we found at least a range for n. We don't know what n is. So n is less than 6, so we can eliminate choices D and E. So n is either 3, 4, or 5. All right. So n is either 3, 4, or 5. Well, let's see what we get. Let's start with n equals 3. If n equals 3, then that means, according to our equations here, m is equal to 96 minus 16 times 3, which would equal 48. Now, is that possible? No, because c plus m is equal to 8n. c plus m is equal to 8n. That's one of the two equations. So if c plus m is equal to 8n, and n is equal to 3, that means that's 24. If m is 48, then that means c is negative 24. Well, that makes no sense, right? Because you can't have negative 24 amounts of coffee. So n equals 3 is not a possibility. All right, cross that off. Let's try n equals 4 with the same equations that we have. The first one was m is equal to 96 minus 16n. So we get 96 minus 16n. 16 times 4, 64. And that means we've got 32 for m. All right, does that work with our first equation? Let's see. c plus m would be 8 times 4, which is 32. If m is 32, that means c is 0. Not allowed because it said that the amount of coffee and milk are never 0. So this is no good. So by process of elimination, the answer is 5. And you can, of course, plug n equals 5 back into here. M is equal to 96 minus 80, which looks like 16 for m. And if you use this equation, you'll get c plus m, which is 16, is equal to 40, and therefore c is equal to 24. And these work. So therefore, n is 5, and that would mean the number of people in the family is c. When the mean, median, and mode of the list given are arranged in increasing order, they form a non-constant arithmetic progression. What is the sum of all possible real values of x? All right. So first let's figure out the mean, median, and mode, and then I will talk about this arithmetic progression. So we have this list, and I'm going to arrange it in increasing order. 2, 2, 2, 4, 5, 10, and then we've got an x, and we don't know what x is. So first of all, what is the mean? The mean, of course, is just the values all added up divided by the number of values. So this looks like 2 plus 2 plus 2 plus 4 plus 5 plus 10 plus x all over 1, 2, 3, 4, 5, 6, 7 numbers. So this looks like 25 plus x over 7. So that takes care of the mean. How about the mode? Let's look at the mode next. The mode is the number that appears most often, and in this case it's 2. Right? Because even if x is 4 or if x equals 5, it would still not become the mode because 2 appears 3 times. Now let's turn our attention to the median. What is the median? Well, we don't know what is the value of x. So how do we figure out the median? Well, there's going to be different scenarios. The first is if x is less than 2. If x is less than 2, then the way I've written it is correct if I've written it in increasing order. And therefore the median is the middle value, so it would be this 2 right here. So when x is less than 2, the median is 2. Okay? Now, what about if the value of x is greater than 2? Let's say it's between 2 and 4, like this. Then the x is not going to appear where I wrote it. It's going to have to squeeze in here, like this, if I'm writing these numbers in increasing order. Correct? So now the median becomes the middle value, which is x. And then what about the final scenario when x is greater than 4? Then this x is no longer here. It would be after the 4. It's greater than 4, so it would be here. Or it might be here, or it might be there. We don't know. But it doesn't matter. As long as it's after the 4, the median becomes 4, because the median is the middle value. So there you go. There's the mean, the median, and mode. The mean is always going to be this, 25 plus x over 7. The mode is always 2. And the median has 3 different values depending on what is x. So now we have to talk about arranging these numbers in increasing order. Right? That's the next step. These 3 values for mean, median, and mode are arranged in increasing order. So let's start with the first scenario right here, when x is less than 2. So the median is 2, the mode is 2, and the mean is 25 plus x over 7. Increasing order, right? So we have median, mode, and mean. And then how about the next one, when you have the median as x? Well, x is between 2 and 4, so it's greater than 2. So in increasing order, it would be 2 for the mode, and then the median, right? Because x is greater than 2. And then the mean. The mean is 25 plus x over 7. Like that. And then finally, when x is greater than 4, the median is 4. So we've got 2 for the mode. The median is 4. And the mean is 25 plus x over 7. So I have to write them in increasing order, and I did that. All right? Now we get to the final part of the question, which is talking about arithmetic progression. So what do they mean by that? An arithmetic progression is a series of numbers in this form: a plus d, a plus 2d, and so on, a plus 3d, like that. So for example, if a was, let's say, 5 and d was equal to 3, this would be 5 plus 3, which is 8, 5 plus 2 times 3, which is 11, 5 plus 3 times 3, which would be 14, and so on. Dot, dot, dot. All right? That's an arithmetic progression. Now, one of the cool things about arithmetic progressions is that if you subtract 2 terms, they will always give d, like 2 consecutive terms. So for example, if I took this term, a plus d, and subtracted from it the first term, it would just give me d. Similarly, if I took this term, a plus 2d, and subtracted from it the term before it, it would become a minus d like that, and that's just d. So we can use this concept or this fact on these ones. All right? So here we go. So for the first one, before I get started with all the math, is this an arithmetic progression? And the answer is no, it's not, because these are the same. They have to be increasing, see? They have to be increasing by some d, and they're not. So this is not an arithmetic progression. So we can just ignore that first scenario. Now the second scenario, is this an arithmetic progression? Well, looks like it. Let's see. We have to now employ this fact that you subtract 2 to get the d. So I'm going to subtract this from this, right? A plus d minus a, same thing, x minus 2. And that's going to be some difference, d. And then I can use the next term, this one here, 25 plus x over 7 minus x, like that. And that will be essentially what I did down there. And let's solve for this. So we've got multiply through by 7, so 7x minus 14 equals 25 plus x minus 7x. So this looks like 39, and 14 minus 3, 13x, and therefore x is equal to 3. So that means that this is a 3, and this mean is 25 plus 3, which is 28, divided by 7, which is 4. So this became a 4. So this was indeed an arithmetic progression, 2, 3, 4. All right, great. We got one value of x. Now let's work with the next one. We did that. Let's work on this one. Same story. 4 minus 2 is going to give me the difference, d. And then 25 plus x over 7 minus 4. Multiply through by 7. This is going to be 2. So 2 times 7 is 14. Is 25 plus x minus 28. And looks like we've got minus 3, so 17 is x. And that is our other value. And what is our question asking us? What is the sum of all possible real values of x? Well, x is 3 and x is 17, so the sum would be 3 plus 17, which is 20. So the answer to number 14 is E. Let f be the function for which f at x over 3 is equal to x squared plus x plus 1. Find the sum of all values of z for which f at 3z is equal to 7. So we've got f at x over 3 is equal to x squared plus x plus 1. And f at 3z is equal to 7. So we want to use this equation to solve for z. So they're putting in a 3z where this equation puts in an x over 3. So this will allow us to solve for x, and that becomes 9z. So therefore f at 3z is equal to, instead of x, we have to put 9z. So we got 9z there and 9z there. And f at 3z, they've already given us, is 7. So this becomes 81z squared plus 9z plus 1. And this is therefore 81z squared plus 9z minus 8 is equal to 0. And can I reduce this? Sorry, that is minus 6. Can I reduce this? I think I can divide through by 3, and that will give me 27z squared plus 3z minus 2, like that. And I think that's about as far as I can go. And I don't think this is factorable either. So I've got to use our quadratic formula. minus b plus or minus the square root of b squared minus 4ac all over 2a, like that. So this becomes minus 3 plus or minus 9 plus 216 over 54. And therefore minus 3 plus or minus 225. Square root of 225 is 15 over 54. So this looks like minus 18 over 54 and 12 over 54. Right. So what do they want in the question? The sum of all values of z. Okay. So our values for z are these two guys. So they want the sum. So the sum would be minus 18 over 54 plus 12 over 54. And that looks like minus 6 over 54. And the top and bottom divide by 6, which leaves you with negative 1 over 9. So that would be 15 is B. A checkerboard of 13 rows and 17 columns has numbers written in each square, beginning in the upper left corner so that the first row is numbered 1, 2, all the way to 17, second row 18, 19, all the way to the 34, and so on. If the board is renumbered so that the left column, top to bottom, is 1, 2, all the way to 13, the second column is 14, 15 to 26, and so on, some square have the same numbers in both numbering systems. Find the sum of the numbers in these squares. All right, so we definitely need a diagram. So let's try to understand this first before we tackle it. We've got this checkerboard, and I haven't drawn in all the rows and columns because it's 17 by 13. There's 13 rows and 17 columns. So I've only drawn in the first like 4 or 5 columns and rows because that should be sufficient enough to understand the question. Then they're saying, starting in the upper left-hand corner, so this corner right here, they are going to number the boxes or the entries. And the first row is numbered 1, 2, 3, 4, like that, all the way up to 17, where 17, say, is the last box in the first row. And the second row is going to be labeled 18, 19, 20, and so on, all the way to 34. All right? So that is the first part of the question. The next part says that if the board is renumbered so that the left column is now top to bottom labeled 1, 2, 3, all the way down to 13. See what's happening here? They're just renumbering it. And similarly, the second column 14, 15, 16, all the way down to 26. If you do this whole thing, they're saying that some squares will have the same numbers in them. And a good example of that is right here. Do you see how that square has the same number with both numbering systems? So they're saying, first of all, find all those squares and then add them all up. Find the sum of the numbers in those squares. Okay, so I hope you understand that question. So let's proceed. So how do we tackle this question? Well, we have two systems. We have the first system and then we have the second system. And each square is basically in a row and it's in a column. So I will denote the row to be, say, M and the column to be N. So in the first system, every number will be of the form N plus 17, M minus 1. So for example, if you have this 20 here, how did I get that? Well, basically n, which is the column, and that will be the third column, plus 17 times m, which is indicating the row, it's our second row, minus 1. And this gives you a value of 3 plus 17, which is 20. That's how you get the number with this formula right here. Secondly, in the second row, the formula is m plus 13 times n minus 1. So for example, if I wanted to get the 16, which is numbered in red, so it was the numbering in the second system, how did I get that? Well, m, which represents the row, which is the third row, plus 13 times n minus 1. N in this case is the column, so it's the second column, minus 1. So that becomes 3 plus 13, which is 16. All right? So those are the two equations. Now we want boxes where the numbers are equal, where these two are the same. So that basically means we have to equate them. N plus 17m minus 1 has to be the same as m plus 13n minus 1. Right? So solving for this, we get n plus 17m minus 17 is equal to m plus 13n minus 13, like that. And therefore, looks like we're going to get 16m, and put everything on one side. So 4 and minus 12n, like this. And then divide through by 4, and we'll get 4m minus 3n. There we go. So this is what we have to work with. Now our m's represent our rows, correct? And how many rows were there? Between 1 and 13 rows. And our n represents our columns. And how many columns were there? There was between 1 and 17 columns. So we have to find all the solutions of that equation with these boundaries. So our solutions for mn are going to be 1, 1. That's our first one. 4, 5. 7, 9. 10, 13. And finally, 13, 17. These will satisfy this. And this is the most we can get because we have to stay within our boundaries. We can't go beyond that. Now we have to figure out is what was the number in that box. Correct? So how do we figure out the number in that box? Well, we can use either of these formulas here. Either one will suffice. I'll just use the first one, n plus 17 times m minus 1. And if you substitute each of these into here, you will get 1, 56, 111, 166, and finally 221. So these are the numbers that are in those boxes that when they are labeled in both systems, they will be the same. So remember, I got the first one just by labeling, but there's also 4 others that when you were to do this whole numbering system in blue and in red, the boxes will contain that same number in both systems. So that's what these numbers represent. And they want the sum of all of these. So the sum is equal to 555. So the answer for this question is D. A circle centered at 0 has radius 1 and contains the point A. Segment AB is tangent to the circle at A, and angle of AOB is theta. If point C lies on OA and bisects angle ABO, then OC is. All right, let's draw this out a little bit bigger. So we're going to have to label this. OC is what they want us to figure out, so let's call that X. And then they tell us that AOB is theta, and they've already labeled that. Point C lies on OA and bisects angle ABO. So ABO is this angle right here, this whole angle, but it's been bisected by C. So therefore, this angle in here is the same as this angle in here. And let's call that M. Like that. Okay, anything else that we can label? Well, this is a tangent point, point A, so this is a right angle. And I think that's it so far. So now, before I progress with this question, there's just one quick thing I need to review. It's called the law of sines. And the law of sines basically states that if you have a triangle like that, and you've got A, B, C as the points, and their sides are of the lengths A, B, and C, that A over the sine of A is equal to B over the sine of B is equal to C over the sine of C. So A is the length of that side, and this A is this angle. All right? So that is something that we will have to utilize in this question. So the first thing is I want to find OC in terms of some thing that they gave us in our opening stem, because currently OC is just represented by X, and that's not going to help us. We have to figure out what X is. So I will do that by using the triangle BOC. So this triangle right here. In that triangle, I will use the law of sines as follows. BC over the sine of theta is equal to OC over the sine of M. All right, so I hope you understand how I use the law of sines on that triangle BOC. Now BC we can keep as is for now, but OC I'll put in my X, that variable that I introduced earlier. So there you go. Now the next step is looking at this triangle right here, BCA. And in that triangle, we'll be able to get a relationship with BC using this angle M. The sine of M is equal to AC over BC. Correct? Now, I've introduced AC, but AC, if you pay close attention, since the radius is 1, this whole thing is 1, and OC is X, AC is just 1 minus X. So therefore, the sine of M is equal to 1 minus X over BC, and therefore BC is equal to 1 minus X over the sine of M, like that. So this is very helpful because now we can substitute this back into there. So we've got BC is equal to x over the sine of m all over sine of theta. BC is this right here. So that means 1 minus x over the sine of m over the sine of theta is equal to x over the sine of m. Cross multiply and you'll get x sine theta is equal to 1 minus x over the sine of m times the sine of m. These cancel, so we've got x sine theta is equal to 1 minus x. Put the x on the other side, we get x sine theta plus x. Factor out the x and you'll get sine theta plus 1. And finally, x is equal to 1 over 1 plus sine theta. 1 over 1 plus sine theta. So let's see. That would be 17D. In year n, the 300th day of the year is a Tuesday. In year n plus 1, the 200th day is also a Tuesday. On what day of the week did the 100th day of year n minus 1 occur? All right, so I'll draw a little calendar for this question like this. And then we are told that the 300th day of year n is a Tuesday. So like this. So we then have to go forward into the year n plus 1. So 301, 302, 303 like that, right? But obviously we're certainly not going to sit here drawing out all of these. So you can use a little trick, which is that every time you get to a 7, it just becomes the same day of the week again. So you can just put this in your calculator and just keep adding 7s, and you'll get that 363. And then therefore 364, and then 365, which completes the year. And then you have day 1 of year n plus 1, the next year, and then like this, 2, 3, 4, 5, and so on. 6, 7, 8. And then similarly, you don't have to keep adding, 1 at a time. You can add 7 at a time, or you can add 70 at a time. So if I start with 8 and I add 70, I'm eventually trying to get to the 200th day. So I'm trying to do that quickly. So 8 plus 70 is 78, and then another 70, 148. And then I can probably just keep adding by 7. And if I do, I'll get to 197. So therefore, this is 198th day, 199, and therefore 200. So the 200th day is a Monday. But the question told me that it's a Tuesday. So what did I do wrong? I went to 365 days, and then I counted 1 to 200. Well, I didn't do anything wrong if the year has 365 days. But the only way the 200th day can be a Tuesday for that following year is if the initial year had 366 days. So that means that year n is known as a leap year, right? 366 days. And if I do that, then this all gets shifted over. This becomes a 1. This becomes a 1, 2, 3, 4, 5, 6, 7. And then all of these get shifted over, and therefore this gets shifted over to here. All right, I hope that makes sense. You can draw it all out if you're not convinced, but the point is that year n is a leap year. Now they're asking us on what day of the week is the 100th day of the previous year, year n minus 1. All right, no problem. We'll just go backwards now. So from 300, I'm going to go backwards. So our trick, or your trick, my trick, was just to keep subtracting by 7s, right? Or you can subtract by 70s a little bit faster. 160, 90, 20, and then subtract by 7s, you get 13, and then 6. So then you have 5, 4, 3, 2, and 1. So the first day of the year N was a Thursday. Now we have to go the 100th day of year N minus 1. So we've got to go back to the 100th day. All right. So this day here, Wednesday, is 365. It is 365 for sure because it's not a leap year, because leap years occur every 4th year. So then from 365, we've got to get back to 100. So we just divide or subtract by 70. So you get 295, and then 225, and so on, like that. $155, and then subtract by 7s, and eventually you'll get down to 106. All right, so that means 105, 104, 103, 102, 101, and finally 100. And that 100 aligns with a Thursday. So the answer to number 18 is A. In triangle ABC, AB is 13, BC is 14, and AC is 15. Let D denote the midpoint of BC, and let E denote the intersection of BC with the bisector of angle BAC. Which of the following is closest to the area of triangle ADE? All right, we need a diagram for sure. Okay, first let's label this A, B, and C. This is our triangle. AB is 13, BC is 14, and AC is 15. D is the midpoint of BC. So I'm going to put D right there. And E denote the intersection of BC with the bisector of angle BAC. So I'll put that there. And what that basically means is that if you're drawing a line that cuts this angle in half, it's going to drop and meet at E. So something like this. All right? So that basically means that this angle is X and that angle is X. All right? And I think so far that's all they've given us. And then what they want us to figure out is which of the following is closest to the area of triangle ADE. ADE. Oh, okay. I got to draw another line from A to D. So ADE. All right, that little triangle inside, ADE, is the area. Okay. So the first thing I notice is that D is the midpoint of BC, right? So if it's the midpoint, it cuts BC in half. So BC is 14, so therefore DC is 7. And therefore so is BD. BD is 7. All right, ED, I'm going to call that Y like this. And therefore BE will be 7 minus Y. All right, and I think that is the extent of all the things I can label. I think that's it. I've exhausted what they've given me. And they want us to figure out the triangle AD, the area. All right, so if we need to figure out area, we have to drop a perpendicular to draw the height. So I'm going to drop a perpendicular from A all the way down to the base like that. And the reason I did that is because that represents the base. I'm going to call it H. H for height. So therefore, the area of triangle ADE is 1/2 base. The base of ADE is right there, which is y. And the height is, well, I just drew it and I labeled it h. So h times y over 2. All right, great. Well, not so great because I don't have either of these yet. So I've got to figure them out. Okay. So here we go. How do I figure this out? Well, one thing I did notice is that this becomes a right triangle, right? A, B to here. I just don't want to introduce any more variables. It's already got too many variables. But that's a right triangle. I hope you can see that. I even wrote that in there. So in a right triangle, you are going to have a Pythagorean theorem relationship. And since this is already 13, if I can make these values become a Pythagorean relationship, it will work for this question. And 5 squared plus 12 squared is indeed 13 squared. And there's no reason why it can't be those numbers. So let's go with that. So now we have one of these variables, which is h. So I've got 12 times y over 2, therefore 6y. So if I can figure out y, which is right there, I will be able to figure out this area. So to figure out y, I have to use something known as the angle bisector theorem. And it basically is as follows. If you have a triangle and then you've got a line that bisected the angle, and you've labeled these A, B, C, and D like that, the angle bisector theorem states that A over C is equal to B over D, like that. So we are going to use that on this triangle right here. Now, which line was it that bisected our angle? It was the line that met at E. Let E denote the intersection of BC with the bisector of angle BAC. So this line right here, that's the line that bisects that angle. All right? So therefore, using the angle bisector theorem, we have the following. 13 over BE is equal to 15 over EC. All right? So I hope that makes sense. Just using that formula. So 13 over BE is equal to 15, but EC I want to write in terms of BE. Well, the full distance from BC is 14, right? So EC is 14 minus BE, like that. And then if you solve for this, you'll get 182 minus 13 BE is equal to 15 BE. And therefore, 28 BE is equal to 182. And therefore, BE is equal to 6.5. All right? So, BE is equal to 6.5. Very carefully, we have to label that. From here to here is 6.5. But we know that from here to here is 5. And therefore, this has got to be the difference, which is 1.5. Like that. Okay, so I hope that makes sense there. And then therefore, how do we figure out y? Well, the distance from B to D was 7, correct? Because D basically was the midpoint. If you remember, D is the midpoint of BC. So from B to D was 7 because the full is 14. And therefore, I'll write it over here. If BD is equal to 7 and BE we calculated was 6.5, right? Then ED has got to be the difference. So 0.5, like that. So I'll draw it again, or I'll highlight it again just to make sure you understand. BD, which is from here to here, is half of 14 because D is the midpoint. So BD is 7. BE, we figured out, was 6.5. And BE is from here to here, all the way till E. So that little guy that we denoted Y is also known as ED, the distance from E to D, and therefore it's got to be 0.5. All right? So that's what we have. We got Y now. So we can solve 6 times Y, which is 0.5, and therefore this is equal to 3. So the area of this triangle is 3, and the answer therefore is C. If X, Y, and Z are positive numbers satisfying all of that, X, Y, Z is. Okay? So we've been given 3 equations, and we have to somehow manipulate them to figure out X, Y, Z. So we've got X plus 1 over Y is 4. Y plus 1 over Z is 1. And Z over 1 plus X is 7 over 3. Okay, so the first thing, what can I do here? I can add them. We got X plus 1 over Y plus 1 over Z plus 1 over X is equal to 4 plus 1 plus 7 over 3. And that looks like 22 over 3. All right, so this was add. Okay, now I can multiply. I can multiply those 3. So X plus 1 over Y times Y plus 1 over Z times Z plus 1 over X. And then on the other side it would be 4 times 1 times 7 over 3. And this looks like 28 over 3. And then now we've got this big long thing. And probably a good idea to get a common denominator. So let's move this up. So this is going to become xy plus 1 over y. This is going to be yz plus 1 over z. And this will be xz plus 1 over x. All right? All right, great. So now we can start multiplying. We've got xy plus 1 on the top, yz plus 1, xz plus 1, and the bottom becomes xyz. And remember, this is what they want us to find the value of, so it's nice that at least we're getting into that territory at least. So now we have to multiply the top, so we've got x y squared z plus xy plus yz plus 1 times this xz plus 1. 28 over 3, and our denominator is xyz. One more big long one here. We've got x squared y squared z squared plus xy squared z plus x squared y z plus xy plus xy z squared plus y z plus xz plus 1. And this is all over xyz, and it equals 28 over 3. All right? Now the good news comes finally that when you start putting them individually, things start to happen here. The first one over this one becomes just xyz. The next one over the denominator becomes just y. And similarly, you get the following. You get x, you get 1 over z, you get z, 1 over x, 1 over y, and finally 1 over xyz is equal to 28 over 3. And before I move forward, this part here, all this stuff looks very familiar. It's this one right here. X plus 1 over y, y plus 1 over z, and z plus 1 over x. X plus 1 over y, y plus 1 over z, and z plus 1 over x. X plus 1 over y, y plus 1 over z, and z plus 1 over x. Right? Exactly the same. And we were told that's equal to 22 over 3. Or we figured that out. We weren't told that. So I can put that in. 22 over 3. And I've got xyz plus 1 over xyz. All right, everything's coming together here. What can I do now? I'm going to let xyz equal a just to make it less confusing. A plus 22 over 3 plus 1 over a is equal to 28 over 3. And we can get rid of this, these fractions, 6 over 3, right? Which is just 2. All right, great. And I can solve for this now. So multiply through by a to get rid of that fraction. So we'll have a squared plus 1 is equal to 2a. Put everything on one side. Minus 2a plus 1 is equal to 0. This factors a 1, 1, negative, negative. And therefore a is equal to 1. Well, a was xyz. And therefore xyz is equal to 1. And that is what they want us to figure out. The value of xyz. So the answer to number 20 is B.